Hey everybody! In this video we're going to talk about graphing a piecewise defined function, problem type 2. So if we're given a function as defined below, what this means is this function is going to be equal, the outputs of this function are going to be equal to this portion if x is less than or equal to 3. And the outputs of this function are going to be equal to this, which happens to be a line, if our inputs are more than 3. So if our inputs are less than or equal to 3, it's going to be a parabola. If it's greater than or equal to 3, it's going to be a line. Now, in order to graph this parabola, we can go ahead and use our translations on this. So I actually, for these kind of problems, I like to graph both problem types. And then, so I like to graph both pieces of the function completely, as if there weren't any restrictions on the x values. And then I like to erase what I don't need and finish off with details. So let's go ahead and graph this whole parabola here. So I'm going to, usually a parabola has a point at 0, 0. I'm going to shift down 2 and to the right 1. And then my parabola is going to open up, and it's going to look like something like this. Now, if I didn't want to do it with translations, how could I graph this? Well, I could say, let's plug in 1. If I plug in 1, I get 1 minus 1, which is 0. 0 squared is 0, minus 2 is negative 2. Okay, there's a point. I could plug in 0, and I'll get negative 1. I could plug in 1, and I'll get etc. So we could plot it that way. Okay. Now, let's go ahead and plot this portion. 2x minus 1. So that's a line at negative 1, and then up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, etc. So it's going to look something like this. But what did I notice? I noticed that, wait a second, it's only this line if x is greater than 3, right? So I can go to x is greater than 3, and I only want this portion of the line, so I can erase the remaining portion of that line. For the yellow part, it's a parabola until x is less than or equal to 3. So these values are all less than or equal to 3 till I get to 1, 2, 3, and I can erase it. Okay. Now the last thing I want to do is make sure my endpoints are correct. For the parabola, we have an equal to sign. So we're going to have a solid dot at 3 on the parabola. But for the line, I can't include 3 in the line. So I'm going to have an open circle at x equals 3, our input of that portion of this piecewise function. Okay, so that is graphing a piecewise function, problem type 2.